this card some time ago. Actually, I was going to use it for a serial card in the Altair. In the end, I used Martin's 2SIO. This is a solid state music IO4 card. It's quite good though, because it's got a couple of parallel ports on the end here, which is composed of that pair of chips and that pair. One sort of output and one's input. And there's two serials as well, which come out here and here. As you can see, some of the ICs are missing. Notably, the serial chips are missing, and they're unfortunately obsolete now. You can still get them, but they're very expensive. So I will at least try and get one of them. Not sure I'll ever manage to fill both of them. But another interesting thing as well is that the minus 12 volt regulator on the end here never ever seems to have been fitted, which is quite intriguing. Another quite entertaining thing as well, I don't know if you can see it, if you look there, they've sort of made their own resistor packs. You see there's a line of resistors and they're all soldered along the top. It's quite entertaining. Then the other worrying thing I found as well is looking down here, that little opto isolator there, it's got the corner chipped off it. Not sure what's happened to that. I think one of the what was the other thing I found? Let's have a look. Oh, this capacitor here. Someone seems to have cut the lead and then soldered it back together again, which is quite entertaining. I don't know what's happened there. It doesn't look too bad on the top. Give me a closer look, but it's fairly reasonable. The transistors look a bit corroded here, but I don't think that's anything to really worry about. The problem comes when you turn it over. Not sure if you catch it in the right light, but someone's used a lot of flux on this. Everything is this sort of white, horrible, creamy colour. Let's see if I can get it. Yeah, I think you can probably see it there. So that's going to have to come off because it is really horrible. I've started cleaning it up a bit in this corner here, and that's come up reasonably well with sort of meths and a toothbrush and a bit of rag. So I'm going to carry on and try and clean the rest of it up. But the rest of it is really ghastly. Some of it's really bad. Just around here. It might not show up on camera, but everything around this area is white with flux. There's an interesting little bit of wire bodge links all over this IC as well. Not sure what's going on there. And the other bizarre thing is if you look down here, they seem to have put some sort of silver loaded paint on the board. Don't know why, because it doesn't go anywhere. It goes down to the fingers here, but they made a little blob at the top, and then the blob doesn't go anywhere, which is really bizarre. And I think there's a little bit around here as well. This bit doesn't look so bad. The bit that's under this socket looks fairly reasonable, so I'll probably leave that. But I'm going to clean this off. I've cleaned one of them off. I'll clean that one off there. I'll just use the back of a knife and again a bit of mess, and that got rid of that. So that's the sort of state of play at the moment. What I'm really interested in is getting these parallel ports to work, because I've got a parallel tape punch and a parallel tape reader that will eventually connect to this. So hopefully at least we can get those bits going. Right, so I'm going to have a good old scrub on this now. When I come back we'll have a little look. Right, I've got everything cleaned up now. Hasn't come out too bad actually. A little look. Certainly a lot better than it was. Got rid of that horrible silver loaded paint down here. That's all gone. I've also removed, where's it gone? Here, all those little bodge links that were around here, they're all gone. I've had to put that little link in there. They'd cut through a track. So hopefully it's back to stock now. At least that's the theory. So that's that one done. I've pulled all the chips out as I wanted to sort of see what the oxidation on the pins was like. A lot of them seem to be almost perfect. This one. No, not that one. I had a really good one. See that one there? You can catch it. See how shiny the pins on it are. They're absolutely perfect. Yeah, some of the other ones haven't fared quite so well. You can probably see at the top of this one, they're quite black. Don't know if that's one of the worst ones, but difficult to tell. I think that probably is one of the worst ones actually. But yeah, there are a lot of them. But I mean, yeah, that one's really bad. Looking at that one, you can see there's a lot of blackening on the top of the pins. I don't think it's a major problem because the bit that's in the socket is still clean. It's still clean on the other side. I'm not really sure I can really clean them up with anything without completely taking the plating off. What I'll do, I'll make a note of them and I'll probably replace those ones. Right. Another thing I did notice, these little things here, I thought these were dill headers, and they're not dill headers at all. They're actually the bottom half of a IDC dill plug. You can see the little insulation displacement pins on the top of them. I've seen these used with wire wrap wire before now, and you just sort of press the wire wrap wire down into the little grooves and then get your links like that. So that might be one useful way of putting the links in when we get to that stage. The other thing I noticed, which I didn't notice before, is that these two regulators here are both plus 5 volt, and this regulator here feeds sort of this row, probably some of those as well, and this regulator here feeds this row down here, which is interesting. So they're just trying to spread the power load out, I suppose. Not seen that done before. The only other thing that did happen during the cleaning process was this poor little disc ceramic capacitor broke off. That was a bit of a casualty. That was in there. I've sort of cleaned that all out with a bit of solder wick, so that'll have to be replaced. So I think before we do anything else, we'll power this up and just check the 5 volts. Is the ideal time to do it because we've got all the chips out at the moment. So let's just put that on there. Right, here we go. Meter over so you can see. We'll put the ground on one of the bolts because that's always the ground on the positive regulators. I've already checked the resistances. There's no low resistances or anything, so nothing nasty should happen on there. Right, should have some power on there now. Right, let's have a look at the top one first. Here we go, 4.97 volts. Right, one down the bottom. Oh, 4.99. Oh, 4.98. It changed its mind. Right, that looks fine. Can't check the 12 volt one because I've not got a 15 volt supply easily to hand. We'll check that when it's in the machine. I don't think it's a major problem. We can do a quick resistance check on there before we plug it in, but other than that should be fine. Right, so I'm going to put the ICs back in now, replace the ones that were missing, and then what we'll do then, we'll have a little look at setting up these switches. I'm not sure how many we need to set, but there's, I think probably just these two. Oh, sorry, I'm missing that one out of the camera. This one here and this one here. That sets the serial address, and that one sets the parallel address. So I'll have a quick look in the manual and we'll check those. There's quite a selection of links and various other things on here. I don't think we really need to worry about those at this point anyway, because most of them are to do with the serial ports, which we haven't got connected. That we do need to set these addresses, otherwise there's a danger that if we have overlapping addresses, then that could cause a serious problem. Right, okay, I'll put the ICs back in. Right, all the chips are back in. I've replaced the ones that were missing other than the two serial chips, the big ones. I have found some on eBay, so they'll hopefully be in part 2. the chips that had the really bad, the oxidised legs, in the end I actually gave them a light scraping with a knife. I had to be fairly careful, but it seems to have worked alright. The only thing that a couple of the ICs had bent legs, the typical thing, you know, someone had put it in a socket and not looked at it and they were sort of folded underneath. I think it was this one and one of the ones over here. So they'll have to be replaced because those legs are sort of hanging by a thread really. They're very, very floppy. Switch wise, all I've had to set is the parallel one here, which is all the switches are set to on. That gives us the parallel at 0 and 1, and I've set the serial ones, which is this one, and they're all switched on but 3, and that puts us at 20 and up to 23. So this one's 20 and 21, and that one's 22 and 23. Right, so I think the first thing we need to do, let's check that voltage that we didn't check earlier. Meter in. So we're just looking for the 12 volts. So let me just pull that out again. Over. Right, let's get on to that regulator. Oop. Right, there we go. There's our 12 volt. Right, so we know that's okay. So that's one thing out of the way. Right. Now what I've done to sort of speed matters up a bit, if you look closely here, I've linked the outputs to the inputs on port 0, and I'll shift this over into the other one in a minute, and so in that way we can drive the outputs into the ins one at a time and then make sure they're all working. Right, so let's just move the camera over to the laptop. We'll check port 0 first. So if I do out 0, 0, we'll set everything to 0. And we go. Now if we do in 0, 0, see we've got 0, 0's come back. Right, so next thing to do, let's set them all high. So if we do out 0, 0, FF, and then in 0, 0, we've got FF. Right, all we've got to do now, if we do a rolling bit pattern, we should be able to check all the lines are okay. So if we do out 0, 0, 55, and then in 0, 0, again we've got the 55s come back. Right, to roll, we'll roll to the left, and if we do out 0, 0, AA, and then in 0, 0, there we go. So that port looks like it's working. Right, the thing to do now is let me shift over the links to the other ports. Right, let's pull that out. Right. Right, okay, I think we're all in the right place now. Let me clear the screen so you can see a bit clearer. Right, so we're on port 1 now. So we'll do the same thing again. We'll do out 0, 1, 0, 0, then in 0, 1. Okay, we've got 0 back, that's good. So out 0, 1, FF, in 0, 1. Okay, we've got FF back. And do the bit pattern now. So we'll do out 0, 1, 55, in 0, 1. We've got 55 back. And finally out 0, 1, AA, and in 0, 1. Right, that looks good. That looks like both of our parallel ports are working. Can't really do much with the serials at the moment. What I can show you, if I get the camera back over, we can at least demonstrate a read and a write to the serial chip. So if we look at pin 4, now if I do out 21, that should flash. No, hang on, sorry, no, that's wrong. I've got that completely wrong. We'll be doing a read, so we need to do an in. So we do in 21. See that flash? Okay, and see the right, we need to be on pin 23. So if I do 21, 22, that's 23. So if we now do out 21, there we go. That's the flash on that one. And we can try the other one. 1, 2, 3, 4. What we need to do this time, we need to do in 23. So we do I 23. There we go. There's the flash on that one. And again on in 23 we do out 23. There we go, there's the flash on that one. So looks like things are more or less working on there. Also we can't be 100% sure, and we've obviously got some configuration to do on these other headers once we actually want to start using the serial ports. So that'll do it for this one, and stay tuned for part 2 when I get the serial chips. Okay, bye.